All right, welcome to OnlineMaths TV. Today we have a very nice challenge on the board. Wow, the question is a bit tough, but we'll solve it step by step. And the question reads, let x, y, z be complex numbers such that x plus y plus z is equal to 2, x squared plus y squared plus z squared is equal to 3, and x, y, z is equal to 4. Then evaluate 1 all over xy plus z minus 1 plus 1 all over yz plus x minus 1 plus 1 all over zx plus y minus 1. So how do we solve this? I'll be solving this challenge with the person of Dr. PK. And like I said before now, that Dr. PK is a man that I trust so much when it comes to solving Olympiad maths, and he's good at what he does. Okay, now you can visit Dr. PK's channel. I'm going to leave a link in the description below where you can get to his channel. And when you get there, subscribe his channel so that you get a solution to some of the tough algebraic and integral challenges. All right, so without much waste of time, let's go into today's challenge. So sit back. Okay, so the first thing we do here, let's take our solution. So let's take solution to this question. Now, the first thing we're going to do here is to equate the whole of this to a constant. So let's assume here we have 1 all over your xy, please, there plus your z minus 1 plus 1 all over our yz plus x minus 1 plus 1 all over our zx plus y minus 1 is equal to p. All we need to do here is easy. Look at the denominator here, look at the denominator here, look at the denominator here. So to find the LCM of what we have here now is going to give us some challenges. Okay, so the first thing we're going to do here is to rewrite this denominator, okay, with regards to what we have in here now. Now, if I decide to make x the subject of the formula from here, and I substitute whatever I have into this expression, that is going to give me y squared and some other quantity automatically is going to give a quadratic function, which will give us some challenge in solving. So what I will do is the z that is standing on its own is what I want to make the subject of the formula from this expression. Okay, so if I make z the subject of the formula from here, it's going to give me z is equal to, here we have 2 minus x, then minus y. Then coming to this side of the expression, I will make x the subject of the formula, okay, from here. So if I make x the subject of the formula, I'm going to have x is equal to my 2 minus y minus z. Again, from this entity here, I will make y that is standing on its own the subject of the formula from here. So here will give me y is equal to 2 minus x minus z from here. If I make y the subject of the formula, right? Good. Now from these three equations, what will I do here? I'm going to pick the first equation and replace it with z here. Second equation x, I replace it with this, and the third expression here y, and replace it here. Okay, so let's take the first one now. From here, let's continue on this side. So the first one we have our x, y plus our z minus 1. If we substitute in, this will give us our x, y plus, look at our z here, 2 minus x minus y. So we have here 2 minus x minus y, then minus 1. Our 1 that is already there. So if we add this and this together, we're going to have x, y minus x minus y plus 1. All right, so from here, we can bracket this and bracket this. So if we simplify x out here, we're going to have x into y minus 1 minus what is common here is just 1. Bracket y minus times plus will give us minus 1. So you discover what we have here and here are the same. So we take the outer quantity and take the inner one. So this will now give us x minus 1 bracket y minus 1. Okay, now if you look at this, in other words, we can replace this quantity with what we have in here. You get that? Very easy. So if we are to put this in place of this, we do same for these two. So for this, we're going to have here our y, z plus x minus 1 is equals to, we are handling this now, right? Good. So we now have y, z plus, what is our x from here? Our x is 2 minus y minus z, right? So we now have this to be 2 minus y minus z there minus r1. Yeah. Right, we have our 1 here, right? Good. So from here, again, we now have y, z. Then we can add this and this now. So we now give us a minus y minus z there plus 1. Again, we cannot put this and this in bracket, put this and this in bracket. So if we do this, y is common here, we now have y, we now have z minus 1, then bring out 1 here minus 1 into z minus 1. Easy. So we take 1 again and this outside. So we now have here y minus 1 close bracket into z minus 1. Again, we've gotten another expression for the denominator here now. We do same for the third expression, the denominator here. So we have our zx plus y minus 1. This is equal to our zx plus, we made our y the subject of the formula. Remember? Look at it. Okay, so we have here 2 plus 2 minus x minus z. Okay, minus our 1 that is here. So from here, we now have this to be our zx, then minus x minus z. Okay, then this will give us plus 1. Like what we did the other time, we cannot separate this and this. Now, what is common here is x. So we now have this to be x bracket your z minus 1 close bracket. What is common here is 1. So minus 1 into z minus 1. Again, this will now give us our x minus 1 close bracket into z minus 1. So we succeeded in looking for expression that we can use for this denominator, and this denominator, right? So from here, what we do, let's go and rewrite the original equation from these expressions we have here now. Okay. All right. So from here, we can now rewrite this expression. So again, we have our p is equal to 1 all over the first expression there. We have x minus 1 into y minus 1. Okay, we draw this way. This plus 1 all over. Again, our second expression we're going to have here, y minus 1 into z minus 1. Then plus the last expression, which is, here we have bracket open x minus 1 into your z minus 1. Easy. Okay. So what are we doing next here now? We can now find the LCM of everything we have here. And if you look at the denominator, you discover that we just have 3 entities. What are they? We have x minus 1, y minus 1, and z minus 1. Those are the things we just have there. So the LCM automatically is going to give us x minus 1 into y minus 1 into z minus 1. So let's go ahead and write this. So this is equal to this all over your bracket x minus 1 bracket y minus 1 bracket your z minus 1. This is all we have from here now. So if we use the whole of this to divide this, we'll be left with what? Z minus 1. So we have this side to be, because if we use this to divide this, left with z minus 1 times 1 will give us here your z minus 1. Okay, let's bring our plus sign here. We use the whole of this to divide this. We are left with what? X minus 1. And we use x minus 1 to times this. This will still give us x minus 1 plus, we use this again to divide this, we are left with what? Y minus 1 times this will give us y minus 1. Okay, all right, so if we add up what we have here now, this will give us, so let's continue on this side of the board again. So all right, from here we can now add our x plus y plus z and this side. So we have our p is equals to our x plus y plus z minus, because here we have minus 1, minus 1, minus 1, so minus 3. Everything all over our x minus 1 bracket y, sorry, yes, y please, y minus 1 into z minus 1. Easy. So we've reduced the complex expression to this level now. So what we do? Now, if you take a critical look at the expression we have at the numerator, x plus y plus z is equal to what? 2. So we can replace the whole of this with 2. So if we do that, so this will now give us here 2 minus 3, everything all over bracket x minus 1 bracket your y minus 1 bracket your z minus 1. Okay, so from here, what we do next? Your 2 minus 3 will give us minus 1. So end up having minus 1 all over your bracket, your x minus 1 into your y minus 1 into your z minus 1. So what we do at this point, all we need to do is just to open the denominator here. So how do we open this? I could as well go ahead to just put in the answer, but let's go gradually, because in some of my videos, most persons ask, how do you jump from here to here? So because of that, I'm going to take everything step by step here. Okay, so let's open this and see what this gives us. So let's use this to open this first. So this will give us x, y. Then this will give us minus x. This will give us minus y. This will give us plus 1. We are having this into what we have left here, which is your 1, z minus 1. So we can now use this to open this now. So we have this to be our x, y, z. Use this to times this to give us minus x, y. We come to this. This time this will give us minus x, z. This time this will give us plus x. Then we come to this, y times this will give us minus y, z. This times this will give us plus our y. Then the last term, which is 1 times this will give us plus z. And this time this will give us minus 1. Any confusion? No. Now, let's put our term x, y, z, because that is the only term we're having carrying x, y, z. Then, when I look at this, we're having minus xy, minus xz, and minus yz. So let's bring those terms here now. Minus x, y, minus x, z, minus y, z. And here we are having plus x, plus y, plus z. There, on this side, we now have minus 1. Any confusion? No. Now, if you look at this, okay, now let's go ahead and write this here now, so that we look at what we do next. So this is equal to minus 1, yeah, minus 1 all over this term we have here now, which is x, y, z, minus. Now you discover that this one we're having minus, minus. So we can bring out the minus sign here. So we're going to have this to be x, y, plus x, z, plus y, z, close bracket. There plus, we have here x plus y plus z. Okay, minus 1. Oh, any confusion? Let's erase this. Let's take a careful look at what we have here now. Look at what we have here now. This is given already to be x, y, z is equal to 4. So we can replace this with 4. Now let's come to this side of the equation here. Now this is given to be what? X plus y plus z is given to be what? 2. So we have this to be 2. So if we are now having 4 plus 2, that will give us 6, minus 1, that will give us 5. So we can rewrite the denominator. This is equal to minus 1 all over 5 minus x bracket open y plus xz plus yz. Easy. Okay, so what we do next, here comes the challenge. How do we handle this part of this equation? All we need to do is to look at this expression given here. X squared plus y squared minus plus z squared equal to 3. We have to do some manipulation from this place here. So what am I going to do here? Watch what I'm going to do here now. Now this expression here, so let's handle this. From this expression, we have x squared plus y squared plus z squared, right? This is also our x plus y plus z all squared. We can express this in this format. And again, we are to open this. Let's go gradually so that you don't get confused. So we have x plus y plus z close bracket x plus y plus z. So if we are to open gradually, this will now give us here, this is equal to x squared. So we have x squared, this, we have plus x, y, plus x, z. We come to y, so we now have here plus y, or let's say x, y, because of the alphabetical order. So from here, we're going to have this to be, so here will give us here our x, y, plus y square plus y, z. Y, z, please. Y, z. We come to our z, so we're going to have here plus x, z, plus y, z, plus z square. Okay, this is 2, this is not z, please. This is 2. Okay, now, from what we have here now, we are having x squared, y squared, z squared. So let's bring those terms out now. So we're going to have this to be x squared plus y squared plus z squared. Now, if you take a look at xy, we are having 2xy here. If you take a look at xz, we're having 2xz. And if you also take a look at yz, then we're also having another yz, so 2 of them. So from here, we can now come here and say plus, bring that 2 into, here we have here x, y, plus x, z, plus y, z. So let's put this in bracket. Okay, are we learning something here? Again, if you're new here, do not forget to subscribe, okay? Because at every time we drop powerful mathematical challenges, solution to mathematical problems here. Okay, now look at what we are having here now. Again, look at what we equated to this thing you are having here now. We equated the whole of this to this place. And look at what we are having here. It is this thing that brought all these things we'll try to do here now. Because how do we factor this out from this given entity here now? So all we need to do is to make this the subject of the formula. Okay, so for us to make this the subject of the formula, we move the whole of this quantity to meet this quantity here. Clear? So we want to move this quantity to meet this quantity on the left-hand side and divide through by 2. Okay, so let's continue on this side again. All right, like I said, from here, let's move this to meet this guy here. So from here, we're going to have this to be your bracket, your x plus y plus z all squared minus everything we have in here, right? So we have this to be minus your x squared plus y squared plus z squared. Let's put this in brackets, right? Then is equal to, here we're going to have your 2 into your x, y plus x, z plus y, z. Okay, mind you, we want to make this the subject of the formula, so we are dividing by 2. we equally divide every tier by 2. So this leaves the system. So we are now having our x, y plus x, z plus our y, z is equal to, this is z please, yz, this is equal to, now let's look at the terms we are given here now. What is x plus y plus z? It's given here already to be 2. So we can substitute 2 in here. So we're going to have here 2 all to the power of 2 minus, what is x squared plus y squared plus z squared? It's given here to be 3. So we can put in here 3. This is all over your 2. Any confusion? We are almost there. Okay, so let's factor this out. So this will give us here, this is equal to our 4 minus 3 all over 2. And this will give us what? 1 all over 2. So we're going to have the whole of this expression x, y plus x, z plus y, z, this is y please, is equal to 1 all over 2. Look at what we're looking for here. It is from here we'll come into all this. So the whole of this is equal to 1 all over 2. Okay, so let's go ahead. Okay, from here now, let's just continue from here. Let's go ahead and put the whole of this into this. So we're going to have this to be minus 1 all over your 5 minus 1 all over 2. The equation is easy now. So let's erase the bottom here. All right, so from here, we're going to have our P is equal to your minus 1 all over, to simplify this, we're going to have 10 minus 1 all over 2, which is equal to minus 1 all over 9 all over what? 2. If we flip this over, this will give us what? Minus 2 all over 9. So therefore, our P is equal to, which is equivalent to what we have here now. What we are asked to evaluate is equal to what? Minus 2 all over what? 9. Oh my God. Let me rule this out very well. So the expression here, given this, when evaluated, will give us what? Minus 2 all over P. Oh, so this marks the end to this simple or tough challenge depending on your level of mathematics. Okay, like I said, this is Dr. PK channel where you also see his own a solution to this challenge. Okay, I believe you will learn 2 different things from this challenge. Okay, because we use a different approach, and here I have a different approach. Again, this is OnlineMaths TV, and you know I love you, and every one of us at OnlineMaths TV loves you so much because you are the reason for the existence of this channel. Never forget to drop a comment. Never forget to drop a like. Okay? Bye for now.